Hello and welcome to Dove Biology Apes Lessons to Go. In this video we'll be exploring groundwater pollution. Now groundwater is not immune to contamination. Leaky landfills, waste lagoons, and leaking underground storage tanks can introduce contaminants into aquifers. Here in this image we have a picture of a gas station which has two underground storage tanks. If it's not monitored correctly, and if it's made out of material that's not resistant to corrosion, it's possible for a rupture to form and then the petroleum product to then leak into the ground. Because the ground is porous and permeable, that material then enters into our groundwater source. Now, depending upon its density, if it's less dense, it's going to float on top of the water table. If it's more dense, it will actually seep into the water table and become part of that moving water as it percolates through the ground. The moving contaminant that moves along with our pollutant is called a contaminant plume. Hot in the news is another major source of groundwater pollution, and this is hydraulic fracturing, also known as fracking. This is a controversial method for extracting natural gas from in between rocks, in that it may also introduce pollution into groundwater. Now, with hydraulic fracturing, the idea is that we drill down well below the water table into rock which may contain natural gas, like shale, for example. We then pump millions of gallons of a proprietary mixture containing water and other chemicals under high pressure into that rock. And as that enters into that rock bed, it breaks the rock, it fractures it, releasing the natural gas so that it can be harvested. Now, unfortunately, this high pressure fracturing can also introduce additional fractures which might release the gas and allow it to enter into our groundwater sources. Additionally, the fracking fluid must be stored in these lagoons, which sometimes are poorly constructed, and additionally when things rain, it can also overflow. So either the leaking lagoons or overflowing lagoons can also introduce that hazardous water contamination will occur in shallow, unconfined aquifers near the contaminant source. It's going to happen mostly in these areas because the confined aquifer is oftentimes protected with an impermeable surface called an aquitard. And so until the water from that confined aquifer meets an area where it can be introduced with that pollutant, it's going to be maintained as pretty clean water. Now, the pollutant, as I said, that moves along with the water is going to be called a contaminant plume. And so, depending upon its density, it's either going to move on top of the water or in the groundwater as it flows. Now, contaminant plumes can actually move great distances. Here we've got a example from the El Toro Marine Base in California. They were using a solvent called trichloroethane to be able to clean the jets, and some of their jet fuel containers actually began to leak, and it entered into our groundwater system and began to move. And this particular plume, based upon this image, is about 24,000 feet long. Now, groundwater pollution may go unnoticed for a long time because groundwater moves slowly, and unless that pollutant enters into a known well and that we've pumped out the pollutant, we know it's present, we're not going to detect it. It could take hundreds or thousands of years for the contaminated groundwater to cleanse itself of degradable waste. The availability of oxygen and microbes that would be able to degrade that waste is a major limiting factor. Additionally, there are some wastes that are completely non-degradable, like heavy metals, and they're going to be there permanently unless we can dig down, actually remove that soil and water, and dispose of that in a hazardous waste landfill, and that is timely and costly. Now, the key to reducing water pollution, especially groundwater pollution, is just to prevent it from reaching those bodies of water. So we have to monitor our landfills and underground tanks to make sure that they're not leaking, and store our harmful chemicals above ground so that we can monitor them. Now, cleanup of groundwater pollution is really dependent on the physical and chemical properties of that pollutant. For some pollutants, we need to drill down and actually pump the pollutant out up to the surface so that it can be treated and then properly disposed of. In other cases, depending upon the type of chemical that we're dealing with, we might actually inject down into the pollutant certain bacteria along with nutrients and oxygen so that the bacteria could bioremediate. The bacteria will actually consume the pollutant and convert it perhaps into a less harmful substance. Additionally, we might be able to employ the use of plants through the process of phytoremediation. Certain plants are able to sequester certain toxins into their system, and through their normal life processes, they're actually able to remediate that toxin and produce less harmful forms as well. Now, our groundwater in the United States is protected by certain laws. The Safe Water Drinking Act is the main law established to protect the quality of our drinking water in the United States. This law focuses on groundwater or other underground sources of water. Groundwater is our main source of drinking water in the United States and across the world. Pollution of groundwater is something that's hard for us to detect. So it's best for us to find ways to protect this essential resource so that we'll have ample drinking water, water for sanitation, and water for agriculture well into our